Hey, Wagwan, it's Mr. Garfield here, and we're going to be looking at January 2018 matrices question, right? This is from the January 2018 past paper, and this is CSEC mathematics, all right? And we're focusing on section 9, that's vectors and matrices. So it says that the matrices A and B are given as matrix A, negative 1, 0, 3, 2, and matrix B, that's negative 3, 2, 1, 1, 4, 6. All right. Yes. So let us begin with the first part of the question, which says that we are to determine A inverse. All right. That's the inverse of A. Okay. So let's do that here. So part one, solution. We know that the matrix A is equal to negative 1, 0, 3, 2, right? Good. This is what we call a 2 by 2 matrix because this matrix has 2 rows and 2 columns, right? And we need to find the inverse of this matrix. Now, when you're finding inverse, right, there are 2 things that you need to figure out. We're going to figure out the determinant of the matrix, all right? The determinant of the matrix is just a number associated with this matrix, right? So what we do is multiply the elements in the leading diagonal, right? Or the main diagonal. So multiply those elements, right? Those are the elements in the main diagonal. So that will give us negative 1 multiplied by 2, all right? And then we minus the elements in the anti-diagonal, all right? So we do that in blue. These are the elements in the anti-diagonal, all right? That's 3 and 0. So that's 3 multiplied by 0. Okay, so I can now say that the determinant of the matrix A is equal to negative 1 times 2 is a negative 2, minus 3 times 0 is 0. So therefore, the determinant of the matrix A is negative 2. All right, good. And there's also something else that we need to figure out, which is the adjoint of the matrix. All right, let's write that over here. The adjoint ADJ of the matrix A. Now, what is the adjoint? Now, to calculate the adjoint, what we do is switch the elements here in the main diagonal. So we switch the positions of the elements here. That's negative 1 and 2. So it means that 2 will come here, all right, and negative 1 will come here. And for these elements here in the anti-diagonal, the one in the blue, we are going to multiply those elements by a negative 1, all right? So if I do that, I will get 0 here, and I will get a negative 3 here, all right? And that is known as the adjoint of the 2 by 2 matrix A. Good. Now the formula for finding the inverse, all right, is going to be what? Hopefully you remember, it is 1 over the determinant of the matrix, all right, multiplied by the adjoint of the matrix. Okay, so that is the formula that we'll be using here. So the inverse of A is 1 divided by a negative 2, right? But in mathematics, we don't like to leave, we don't like to leave a negative number in our denominator. So I'm going to put the 2 here, and I'm going to put the negative to the side. You can either put it to the side or to the numerator. All right, so we have negative a half there, and we're multiplying that by the adjoint of A, which is 2, 0, negative 3, negative 1. All right, good. And that is known as the inverse of A. Okay, that is the inverse of A. Now, you don't have to multiply the negative a half inside. All right, you don't have to, but you can if you feel to. all right? But you can stop right there. Once you stop there, then you know that you have gotten the full marks for the inverse. Okay, good. So we are now finished with part one of the question, all right? So we'll finish with part one here. Part two now says we're to show that the inverse of A multiplied by the matrix A is equal to I, where I is known as the identity matrix. All right. Now, what is the identity matrix? The 2 by 2 identity matrix. All right. So the 2 by 2 identity matrix is going to have one. All right. It's going to have one in the main diagonal. So one will be here, one will be here. And in the anti-diagonal, we're going to have 0. All right. So when we multiply A by its inverse, all right, we're supposed to get that matrix there, 1, 0, 0, 1. Okay, let's do that here. So this is now part 2 solution, right? So part 2 solution, we're going to multiply A inverse by A. We know that A inverse is negative a half, all right? Multiplied by 2, 0, negative 3, negative 1, okay? And the matrix A now, multiplied by matrix A, which is negative 1, 0, 3, 2. Okay, good. Now, remember now that when you multiply matrices, we multiply using the row and the column, right? So multiply the row of the first matrix by the column of the second matrix. All right, that is important. So I'm now going to multiply the first row, all right, the first row by the first column, okay? The first row by the first column. In my matrix down here, the first row and first column, all right, that element will be here, right? Right there. Good. So just now write in our entry. So we're gonna have 2 multiplied by negative 1 plus 0 multiplied by 3. All right, good. Now I'm going to multiply the second row, the second row, sorry, yeah, the second row by the first column, right? That's the second row here by the first column here. All right, in my matrix, I know that this will be that element there, right? The second row by the first column. All right, that is where my entry will be. Let's just write down what that would be equal to. That would be a negative 3 multiplied by a negative 1 plus the negative 1 multiplied by 3. All right, good. So we're finished with the first column. Let's now deal with the second column. All right, so I'm now going to multiply the first row by the second column. All right, in my matrix, this element would be in the first row, second column. Okay, so what would my entry be now? That would be 2 multiplied by 0 plus 0 multiplied by 2. All right, good. And my final element now, all right, that will be right here, all right, and that would be the second row by the second column. All right, so second row multiplied by the second column. So what will that give me now? That's going to give me a negative 3 multiplied by 0. All right, let me write that a bit better. Negative 3 times 0 plus a negative 1 times 2. All right, that will be my element. Good. Let's simplify now. So we have a negative a half on the outside still, and we know that negative 2 will be here, right? Negative 2 will be here. 2 times negative 1 will give us negative 2. 0 times 3 will give us 0, right? And 3 will be here, right? Negative 3 times that negative 1 will give us positive 3. And a negative 1 times 3 will give us a negative 3. We know that 2 times 0 is 0, and 0 times 2 is 0. Negative 3 times 0 is 0, and negative 1 times 2 will give us a negative 2. Okay, let's now simplify further. So negative 2 plus 0 will give us a negative 2. This will give us 0 here, right? 3 minus 2 will give us 0. 0 plus 0 will give us 0. And 0 minus 2 will give us a minus 2 here. All right, good. So I'm now going to perform scalar multiplication here now. So I'm going to use a negative a half on the outside and multiply it by each element inside the brackets. All right, so we're going to have negative a half. So we're going to have negative a half multiplied by the negative 2. All right, we're going to have negative a half multiplied by 0. We're going to have negative a half multiplied by 0 and negative a half multiplied by a negative. Okay, so if I do that now, what will I get? Well, I could cancel out the 2's here, and I could cancel out the 2's here as well. All right, so if I do that, I know that I will get a negative 1 times a negative 1 is a positive 1 here. Down here, I know that negative a half times 0 is 0. All right, so we'll have 0 here as well. And negative 1 times negative 1 is a positive 1. All right, so that is 1, 0, 0, 1, which is what we wanted. And that is the matrix I. All right, so A inverse multiplied by A is equal to I. And that is what we wanted to show. So we can now come down here and write shown. All right, we can now write shown. That is what we wanted to show. Good. Okay, and that is the end of the second part of the question. All right. All right, so I hope you understood that. Let's move on to part 3, which says we are to determine A squared, right? Determine the matrix A squared. So that's part 3. Let's write that down here. This is now part 3 solution. Part 3 solution. Good. Now we know that, let me just scroll down a bit here. We know that the matrix A is equal to negative 1, 0, 3, 2. All right. Now I'm going to write down something and you tell me if that is correct. So if I know that A is equal to that matrix, then A squared is equal to negative 1 squared, 0 squared, 3 squared, 2 squared. All right. And we can simplify A squared to be negative 1 squared, that's 1, 3 squared, that is 9, 0 squared is 0, 2 squared is 4. All right, so is this correct? We're squaring the matrix A, right? So I'm asking you, is that the correct answer? Well, if you said yes, then you are absolutely incorrect. All right, that is incorrect. I participated in a CSEC mathematics workshop recently, and the students told me that this matrix here would be the answer, but it is incorrect. Okay? So do not square each element inside of the matrix. All right? That is a no-no. What you should know is that A squared, the matrix A squared, means we're multiplying A by itself. All right, so A times A. So I can say that this is equal to the matrix -1, 0, 3, 2 multiplied by -1, 0, 3, 2. Okay, good. So let us now perform our multiplication here. All right. Now let me multiply the first row by the first column. All right. So it means that my entry will be right here. All right, that's where my entry will be. Let's write that down. That's going to be a -1 multiplied by a -1 plus, we're going to have 0 multiplied by 3. All right, good. Now I'm going to multiply the second row by the first column. All right, which means that my entry will be right here. All right, so just calculate that. So when I multiply now, I will get 3 multiplied by a -1 plus 2 multiplied by 3. Okay, good. So I'm finished with the first column and I'm moving on to the second column. Okay, so what I'm going to do now is to multiply the first row by the second column. All right, so first row, second column, which is going to be right here. All right, so that's -1 times 0 plus 0 times 2. All right, that is what I will have. And my final element is going to be from the second row by the second column. All right, so second row times second column, which will give us 3 times 0 plus, we're going to have 2 times 2. Okay, that is our matrix A squared. Let's just simplify it a bit. So -1 multiplied by a -1 will give us a +1, and 0 times 3 is 0. 3 times -1 is a -3, plus 2 times 3 is 6. -1 times 0 is 0, plus 0 times 2 is 0. 3 times 0 is 0, plus 2 times 2 will give us 4. Okay, and this is going to be equal to 1 plus 0 is 1, 0 plus 0 is 0. All right, -3 plus 6, or 6 minus 3, will give us 3, and 0 plus 4 is 4. Okay, and that is my matrix for A squared. Okay, so that is the end of this part of the question. All right, so that's part 3 completed. Now we're moving on to part 4A, which says that we are to explain why the matrix product AB is not possible. All right, why it is not possible. So let me do that here. So we're looking at part 4A. All right, and it says that we are to explain why the matrix product AB is not possible. Now, we're going to be looking at the order of both matrices A and B, right? So in order to answer this question, we're going to look at the order of matrix A, all right? And we're going to look at the order, of matrix B as well, okay? Now, we already stated that the order of matrix A is 2 by 2, right? That's a 2 by 2 matrix because it has 2 rows and 2 columns. But what about matrix B? Well, if you observe the matrix B carefully, it has 3 rows and 2 columns, right? 3 rows and 2 columns. Let's write that down here. That's 3 rows and 2 columns. Okay. And remember, they asked us to explain why the matrix product AB is not possible. So remember now we're dealing with order. We use row multiplied by the column, right? That's how we state the order of the matrix. Good. Now, in order for the matrix product AB to be possible, it means that these numbers here have to be the same. All right, they have to be the same in order for the product to be possible. All right, but you recognize that they are not the same, right? Those two values are not equal. Okay, so what will be our reason here? So we're going to write a statement. So the matrix product A times B is not possible. All right, it is not possible since, now if you look carefully, the column of matrix A, the number of column of matrix A is not equal to the number of rows in matrix B. All right, so remember those two values must be the same. So that is our reason. So it is not possible since the number of columns in matrix A is not equal to the number of rows in matrix B. All right. So in order for the product to be possible, it means that the number of columns in the first matrix must be equal to the number of rows in the second matrix. All right. But in this case, it is not so. So it means that the matrix product is not possible. Okay? Because 2 and 3 are not the same values. All right. So we have now completed part 4A. Now we're going to do the final part of the question, which says, without calculating, state the order of the matrix product BA. All right. So part 4B now. Let's do that here. Part 4B, solution. All right. So it says that without calculating, we are to state the order of the matrix product BA. So we're going to look at the order of the matrix B and the order of the matrix A. All right. So order of matrix B, sorry, B is first, right? The order of matrix B and the order of matrix A. All right. That is what we'll be looking at here. Okay. Now the order of matrix B, we had already stated, is a 3 by 2 matrix, and the order of matrix A, we had already stated, is a 2 by 2 matrix. All right, and we know that we're dealing with row by column. Okay, now what do you recognize here now? These two values now are the same, aren't they? Right? Those two values are the same, which means that the matrix product B times A is possible. All right, so the matrices are compatible for multiplication. So, and remember the question said that we are to state the order of the matrix B times A without calculating. So once those two elements there are equal, then we know that the matrices can be multiplied. And these two numbers here is going to give us the order of the matrix. All right, those two numbers there in the green will give us the order of the matrix B times A. So I can now say that the order of matrix B times A, all right, is going to be 3 by 2, right? Those elements in the green there, those two numbers in the green, 3 by 2. So the matrix B times A, all right, the order of that matrix is 3 by 2, which means that it has 3 rows and 2 columns, all right? And that is the solution to that part of the question. And we are now finished with this past paper question, all right, from the January 2018 paper 2. Okay, so I hope this was helpful. If it was, please ensure to like this video, all right, comment down below and subscribe to the channel. Okay, I am Mr. Garth Reed, student ambassador in the University of Technology Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.